In this video, we'll be going over the solutions to lab problems from week 5. And in week 5, we're kind of switching gears a little bit and we're starting to talk about vectors and the vector forms of lines and that sort of thing. So jumping right into the first question is asking us to find two things. So first thing is we have to find the vector equations for a line, and then the second thing is that we have to find the parametric equations for the same line. Okay, so we'll start quickly by going over what it means to have a vector equation for a line. So a vector equation for a line, you need two things. So for a vector equation, we need two things. So one is that we need a point. So we need a point that's on our line. The second thing is we need a direction vector. Okay, so we need these two things in order to make a vector equation for a line. So the first thing here, well, we have 2 points in this question. We have this guy here and this guy here. So we do have a point, but we don't really see right away that we have a direction vector. So in order to find a direction vector, and it's given right here in the question, but I'll go over it still. So it says a direction vector of the form this guy. So essentially what you're doing is you're taking this one point and you're subtracting this other point. And I'll show you what it looks like here. So for example, if you were finding the direction vector, if you wanted to find a direction vector, you could just take your one vector here. So which one is this one? We're going to label it like this. We're going to go P and Q. We're just going to call our vectors these symbols. And so we have Q minus P. And so we're going -7, 6, 0. And if we do this, so if we subtract these 2 points, we're going to get a direction. So, and it's going to be of the form 6, -5, and 4. So this guy right here that we just found, and we just found it from using this formula here that we're given, which is we essentially are subtracting these points from each other. So when we do that, we end up getting this vector right here, and this is our direction vector. Okay, so now that we've done that, we can see that yes, in fact, we have a point and we have a direction vector. So now how do we write the vector equation for a line? Okay, so the way that we write it is we want to have our variables, so our x, y, and z here, and we're going to have it equaling, we need to equal a point plus our direction vector. As we just talked about, you need a point and a direction vector. So this plus our direction vector. So at the point, you can either pick P or Q here. It doesn't really matter. You can pick either one. In this case, I will just pick P. So we can go something like this. So a point on our line, and then our direction vector that we found is 6, -5, and 4. And one more thing that we have to do is that we have to add in a parameter. So we have to add in something like this. So t times this direction vector. And the reason that we do that is because the direction vector, it only gives us a direction. So in other words, if we have some line like this and our direction vector is here, we can have a whole bunch of different multiples of that, and it's still going to be an accurate representation the direction of our line. So in other words, we can multiply this direction by any scalar. So we can have scalar multiples and it's still going to represent the same direction, just scaled differently. So that's important that we remember to put this guy in there. So when you're doing, just to recap, oops, that's not an eraser. So just to recap, when we're doing our vector equation of a line, we need two things. One, we need a point, and two, we need a direction vector. The way that we find a direction vector is we simply, if we have 2 points here, like we have in this example, so if we have 2 points here, like we have in this example, we simply subtract the point from each other, and that gives us a direction. Okay, so that will give us our direction vector, and then to write the actual equation of the line, in this case, we would write our xyz is equal to our point plus t times our direction vector. Okay, so that is how you write the vector equation of a line. So we're done the first part here, and now we have to move on to the second part, which asks us to find the parametric equations for this line. Okay, so parametric equations for this line, you see the root word here, it says parameter. So all we're going to do with this is, now that we have our vector equation, we're simply, you can think of it kind of like you're writing the equations out, like you're expanding, you're taking it out of vector form, so into a form that you're perhaps more comfortable with, so or more used to at least. So the parametric equations would be, you're taking it out of your vector form, so, and writing in your parameter here. So I guess I could write 6t instead. So your parametric equation for your x right here would just be, you're just writing out your row essentially with your t in there also. So you see that you have, right here you have x equals -7 plus t times 6, so 6t. And we're just going to do that for all of the other ones as well. So we take out y and we look on our row here and we see that y equals 6, y equals 6 minus 5t. Okay, and then our z, same thing, we just look on our row here and we see that our z just equals 0 plus 4t, so we can just write 4t for this one. But these guys right here, these guys give us our parametric equations. Okay, so that's basically all it is then. So parametric equations, you're just you're just writing this, essentially this whole thing here, you're writing it but not in vector form, so in an equation form which you're more used to. So that's your parametric equation, and vector equation, you're writing everything as a vector, so essentially a n or an m by 1 matrix, you can think of it like that. Okay, so this question is the same thing, except for now they don't tell us how to do it. So now we have to remember how to do it on our own. So we have 2 points here, which is nice because that's going to help us find our direction vector. So we'll go over one more time. We need to find the vector equation for the line that goes through these 2 points, and then we need to find the parametric equations. So first thing we're going to do is we're going to find the vector equation. Oops. So we're going to find the vector equation, and if you remember from the last problem, we need 2 things. So our first thing that we need is a point. So we need a point, and the second thing that we need, hopefully you guys remember this, is direction vector. from just looking at our question, we know that, okay, we do have a point. In fact, we have 2 points, but we don't have a direction vector right now. So what we're going to need to do is we're going to need to remember how to find our direction vectors. So what we can do is we can just take these 2 points and we can just subtract them from each other, and that will help us to find our direction vector. So let's go with 2, 2, 4 minus -5, 5, 1, and that will give us 7, -3, 3. Okay, so we're just subtracting the 2 points from each other, and we end up with this guy. And this guy is our direction vector. Okay, so now we look back, and yeah, we have all of the things that we need to satisfy the vector equation of the line. So we're going to go ahead and write it. So if you remember from the last question, we wrote it like this. So we have x, y, z. And then we're going to have it equaling to a point. So a point, it doesn't matter which point, plus t, so t times our direction vector. Okay, so we can pick whatever point we want. Let's go with -5, 5, and 1. And then we write in our direction vector, which is 7, -3, 3. So this whole thing right here, this is our solution. This is our vector form of the line, vector equation of the line. And next thing that we have to do is we have to find our parametric form. The parametric form, if you remember, it's just we're extracting these equations from our vector form. So we're just writing it in equation form, essentially. So we can write x equals -5 plus 7t. And we get that from just from looking at here. And then our next one, we're going to do our y. So our y equals 5 minus 3t. And our z right here, our z equals 1 plus 3t. And I guess I didn't mention this in the last part, but I should have mentioned it. You should always write that your t is the element of the real. So that just means that t is any real number. So we can multiply our direction here. We can multiply our direction by any real number t, and it's going to still give us a vector that's in the direction of our line. Okay, so I forgot to mention this last time, but make sure that you write this down. So this question is asking us to find the parametric equation for this line right here. So this is just a line in 2 dimensions, and we have to find parametric equations for it. So basically, parametric equations means that we want to have y and x in terms of another parameter. So we want to write it in terms of some other, we want these in terms of some other parameter, we'll call it. Okay, so let's start with what we know. So we have that y equals x minus 5. Okay, so since y equals x minus 5, and we want to write these guys both in terms of another parameter, then let's just say y equals t, where t is some real number. Okay, I know this is confusing at first, but bear with me, it will make sense. So we're going to just arbitrarily choose y to equal t, to equal some real number. Okay, so since we have y equals x minus 5, and we just set that equal to t, well, now what we want to do, because remember our initial goal, now we have y in terms of some other parameter, but we don't have x in terms of some other parameter, right? So that's what we have to do next, is now that we know we have this whole equation here, now we have to basically isolate for x. We need to find what x is in terms of t. Okay, so we need x in terms of t now. Okay, so what we're going to do is we're going to write x minus 5 equals t, because remember y is equal to t. So we have x minus 5 equals t, and all we have to do is isolate for x. So we can go x equals t plus 5. And then now we see we have exactly what we want, right? First of all, we have y in terms of t, and now we also have x in terms of t. So this is our goal, to write it in terms of another parameter. So now what we can do is we can write our solution is y equals t and x equals t plus 5. And this I guess I should also write where t is an element of the real. So t is just some real number that we're putting x and y in terms of. So this guy right here, this is our solution. Okay, I know it's a little bit confusing, but just think of it as, okay, if I'm given an equation, a simple equation like this, I'm just going to set my y equal to something. So to another parameter, I'll set it equal to t. And then from there, you can just isolate for x to get x in terms of t. So that's all we did in this. We just put our variables of our equation in terms of something else. Okay, these questions are pretty fun. I think you guys are going to like them. They just take a little bit of getting used to, but once you can visualize what's going on, it's much easier. So what I'm going to do right now is I'm just going to draw a line here, because what we're given is that we have to find a point on a line segment, and we know that P and Q are in our line segment because it says from P to Q, and we have to find it, which is 1/7 of the way from P to Q. Okay, so what I'm going to do is, we know that P and Q are on our line segment here, so I'm going to draw in P, and I'm also going to draw in Q over here. Okay, and I'll draw in I'm going to call it, this point here, I'm going to call it R. So this guy is 1/7 of the way from P to Q. Okay, so we've got to find that guy. So first, the most important thing when we start these questions is that we have to realize that these points that are given to us, so our P and our Q here, they're not just random vectors like floating in space. We should think of them as vectors that are starting from our origin. So really it's more accurate to write OP and OQ here. Okay, so it's starting from some origin and it's pointing to that point. So I'll show you guys what you should do. So you should make sure that you draw an origin here. So draw an origin somewhere over here, because your vector is going to be pointing from the origin to your point. Okay, so what that looks like is we know that our vector points from the origin to our point here, and our vector Q or OQ is pointing from the origin to Q over here. Okay, it's a little bit off, but that's okay. So we can actually write that in. So we have -4, 7, and 5, and over here we have 2, -2, and -3. So those are our points that we're given. We need to find R. So because we need to find R, we know that we need to find OR. right? So we need to find the origin to R. And this should make sense because, as we just talked about, our vector here, our P is actually OP, and our Q is actually OQ. So then our R here should be OR. Okay, so that's what we're trying to find. I guess we should quickly go over the tip to tail method. So I'm not sure if you guys remember this, maybe you went over it in class, but I'll just give you a quick reminder. So if we have some vector and we have, let's call this guy U, and we have another vector here V. Okay, the way that we add them together is we would go tip to tail. So our tail is this guy right here, this part, and our tip is this guy right here. Okay, so same thing on the other one. This one is our tail, and this one is our tip. Okay, so we're gonna add vectors from the tip to tail method. Okay, so first thing that we're gonna do, we just start off with our U vector here. We have our U. We know that we have to go tip to tail, so this tip has to touch the tail of V if we're adding U plus V. We know that the tip has to touch the tail, so we do something like that, right? And that makes sense because we have our tip of U touching our tail of V, and the resulting vector, so the U plus V is actually, I'll write my U over here, is actually going to be this guy. So our is actually going to be right here, U plus V. I guess I can do this too. So our resulting vector, so adding them together, it's taking me from here all the way to over here. Okay, so this vector right here, the U plus V, that's going to represent adding U to V, adding the vector U to the vector V. Okay, so if you guys are not familiar with that, then just do a little bit of practice because these type of questions, they do entail some of that vector addition and that sort of thing. So okay, so what are we trying to find? Well, we're going to write it down what we're trying to find. We're trying to find OR. Okay, so we know right now that OR is equal to OP, okay, plus 1/7 of PQ. Okay, and we know that because if we just go like this, you know, we go OP and then we go 1/2 of OQ, then we can see from our tip to tail method that it's just going to result in that guy, right? So it's going to result in our OR, which is what we want. Okay, so right now we see that, but the only problem is that we don't have what 1/2 of P, or 1/7 of PQ is, right? So we know that somehow we're going to have to rewrite this PQ into terms of things that we actually know already. So I'm going to go ahead and write OR equals OP plus, and so what we're going to do now is we're going to think about how can we get what we want from what we already have. So we have OQ and we have OP, right? So if we take something like, for example, if we take OP here, right? So this vector here, and we subtract OQ. So what does subtracting OQ mean? So it's important to remember that these are vectors, so they have a direction. So if you subtract a vector, then, so right now you have OQ is pointing sort of upwards to the left. If you subtract it, it's going to point the opposite way because you're technically adding the negative of a vector. So I hope that makes sense, but so if you take O to Q and you subtract O to P, okay, so which is your O to P is right here. If you subtract that guy, then using the tip to tail method, you're going to get something that looks like that. Okay, and from what you can see is that these two lines here, they are parallel to each other. Okay, so these two lines are parallel to each other. So in that way, what we've done is we have found PQ, or sorry, we have found, the line PQ from just simply using our OP and our OQ. Okay, so it's going to look something like 1/7 of, and what did we do? Well, first thing that we did is we took OQ and we subtracted OP. Okay, so we did that. And that is equal to 1/7 of PQ. Okay, so next thing is we already have all of these things here. We have OP, we have OQ, and we have OP again. So now what we're going to do is we're just going to plug in our vectors that were given here. So we have OP, and our OP is -4, 7, 5, plus 1/7 times, and our OQ is 2, -2, and -3, plus -4, 7, and 5. Okay, so this equals -4, 7, 5, and we're adding 1/7 times, so we're just going to add these two first. So we get 6 and -9, -8, and then when we add these guys together, we get -22/7, 40/7, and 27/7. Okay, and once again we look back up and we see, what does this guy represent? Well, we are trying to find OR, and this equals our OR. So we can write over here that from O to R we have -22/7, 40/7, and 27/7. Okay, I know it's kind of a little bit strange at first, but when you do more problems like this, you will get used to it. So I definitely recommend doing a couple of these of the same type, where it asks you 1/7 of the way. So I'll just quickly recap what the main points are. Okay, so we have a line segment and we have 2 points on the line. Okay, we need to find a point that's 1/7 of the way between those guys. So we always know that we start with the origin. Okay, so we draw in an origin here after we draw our line with our points on it. So we have our origin, and we know right away, since we're given 2 points, we're given our OP and our OQ. We need to find our OR. Okay, or in other words, we need to find the vector R, which is from the origin to our point R. So first thing we do, we write it out. So we write OR equals our OP plus 1/7 of PQ. But we don't know what 1/7 of PQ is, right? So somehow we've got to substitute that with the things that we do know. Well, we know that OQ plus a negative OP gives us a line here, which is parallel to our original line that we wanted. So we know that finding 1/7 of this guy is going to give us the same thing as 1/7 of this guy. Okay, so from there we just plug in our vectors that we have, and we end up with our OR. Okay, this question pretty similar to the last one, except for now we're dealing with 4 points. So we're dealing with a parallelogram. So I'm going to go ahead and draw my parallelogram, and I definitely recommend always drawing your problems out. Definitely helps. So here I'm going to draw my parallelogram. Okay, so we're given that we have 3 vertices of our parallelogram, and we have to find our 4th one. Okay, so we have, I'm going to just draw it in here. So we have A, and we have B, and we have our C, and we need to find D. Okay, so our A, I guess we can just, well, we don't really have to write in the points, but if you want to write in the points, go ahead. But so first thing that I'm going to do is, as always, I'm going to draw in my origin. Okay, so always remember to draw in your origin when you do these type of problems. It really helps. Okay, so first of all, let's assess what do we want, okay? So we've already written down what we have. So we have A, in other words, we have OA. We have B, in other words, we have OB. And we have OC. And what do we want? Well, we want to have OD. Okay, so we want to figure out what our OD is. So same technique as we used in the last problem. We're going to write what we know so far. So let's just write out what we know in vector form. So we have O to A, right? And we know that if we take AD, then to complete this, we're going to get OD, which is exactly what we want, right? So let's just write that out. So OD equals OA plus AD, right? Okay. So what's the problem with this? Well, right now we don't have AD, right? So we need to put AD into a form of something that we know. So we need to put it in the form of OB, OA, or OC. Okay, so we have OA plus. Okay, now this part, little bit tricky, but if you practice it a couple times, you'll get it. So first of all, we know that this is a parallelogram. So we know that the sides here, the opposite sides, we know that they are parallel to each other. So that's going to help us out some. So we don't have AD because, well, we don't have D, right? So there's no way we can find out AD. But since we know that AD, our line here, AD, is parallel to our line BC, well, what we're going to do is we're going to rewrite this, and we're going to say OA plus BC. OD is equal to OA plus BC. That makes sense because these two lines here, they're parallel to each other, okay? So next thing that we're going to do is we're going to say, do we have BC? And no, we don't have BC. So what we're going to do is rewrite our BC in terms of something that we do know. So similar to last time, we're going to want to take something that we know and subtract something else. Okay, so I'm going to go ahead and I'm going to just go from OC. So I'm going to write OC here. So we have OC, right, guys? And what we're going to do is we're going to take OC and we're going to subtract OB. Now OB, just so that I remind you guys, it looks something like this. Okay, so that's OB. Okay, so if we were to subtract that, since you guys know that it's a vector and it has a direction, then it's going to have to look something like that, except for pointing in the opposite direction. So like this. Something sort of like this. Right? Does that make sense? So these guys here, these guys are the same. Okay? And then now what we're going to do is we're going to connect those lines like this. Okay? And this line here is going to represent our BC. Okay? So I'll erase this line so it's less confusing. But this line here is going to represent our BC. Okay? So, and this is in terms of things that we know, right? Because this line here that we wrote down, it's OC, and this one is minus OB, okay? So what we can do is we can just write that down. So OC minus OB, okay? So this is enabling us to figure out what the line BC equals, and in turn, the line BC equals AD. So that's going to help us figure out our AD. So now we see that our equation is in terms of all of the stuff that we already know. So at this point, we can just add in our vector form here. So we know OA is equal to 2, 1, 0, plus we have 1, 3, negative 1, minus negative 3, 1, 3, equals 2, 1, 0, plus, and when we add these two together, we get 4, 2, negative 4, and then adding these guys together, we get 6, 3, negative 4, and this equals, so 6, negative 4, this equals our OD. So this guy equals D. Okay, so if you practice a couple of these parallelogram questions, it's exactly the same every single time. You just have to really think about what you can substitute in here in order to get the right answer. So, I mean, you can think about it without drawing the picture also. You can just, essentially, you know that BC has to be OC minus OB, just from writing the vector equation of line. You already know this, but it's really helpful if you're able to draw it, because if they add in some little twists, or when you get to projections and furthest distance from point to a plane and stuff like that, it really helps to draw things out. So this is, I'm just showing it to you this way so that we get used to drawing things. So quick recap. We draw our parallelogram, we have our points A, B, and C. We need to find D, so in other words, we need to find our OD, so origin to our point D. So we write out right away that, okay, well, if we want to find D, using the whole tip to tail method, then what we need to do is we have to go OA to AD. Problem is that we don't have AD because we don't have D. So we know because it's a parallelogram, these two sides are equal to each other. So we're going to just substitute that in there. So BC. Next thing that we're going to do is we're going to look at how do we make BC out of things that we already know. Well, we know that OC minus BC is going to give us a line that's parallel to our original line that we needed, our BC. And then from there, we plug in our vectors. Okay, so hopefully that made sense. Just takes a little bit of practice.